let's also look at how to calculate electrical efficiency. All right, so let's imagine an old-fashioned incandescent light bulb. Let's say that we put in 100 joules of energy in the form of electrical energy. Let's say, for the sake of argument, and actually it's not a bad approximation, about 5 joules of energy re-emerges as light. The remaining 95 joules of energy is not destroyed, but it is lost as heat. So of the 100 joules that goes in, 5 joules becomes light and 95 joules becomes heat. But because the point of a light bulb is not to generate heat, the heat is useless and we say it's lost. So what's the efficiency of our light bulb? Efficiency is equal to the useful output divided by the input times 100%. So in this case, it's 5 joules of useful light energy divided by 100 joules of electrical energy that we put in, multiplied by 100%, to give us 5%. So the electrical efficiency of our incandescent light bulb, in this case, is 5%. We can also, and must also, talk about electrical watts whenever we're talking about efficiency. The power of an electrical device depends on its voltage, but also on the current that it's drawing. So if you think about that, if you increase the voltage, if you increase the energy of the electrons, the circuit will have more power. It will be a more powerful circuit. Likewise, if you were to keep the energy of the electrons the same, but push more electrons through every second, that is, increase the current, then you would also increase the power of that electrical circuit. Power is measured in a unit called watts, and the symbol is a capital W. Because the power, or the watts, of a device depends on both voltage and current, power can be calculated by multiplying the volts times the amps. So, if an incandescent light bulb is operating in a 240 volt circuit and it's drawing 0.3125 amps of current, its power would be those two numbers multiplied together, which comes out to be about 75 watts. Now, you might wonder, how in the world would I know that a light bulb was drawing 0.3125 amps of current? And the answer is that you'd have to connect it to an ammeter and find out. Or you'd have to work backward. You'd have to say, buy a light bulb with its power in watts stamped on its packet. Wire it into a volt you know to be 240 volts, and then rearrange this equation in order to find the missing missing current, 0.3125. And in reality, that's how I cooked up this example for you. That is how we calculate the sorts of numbers that we need to calculate in order to talk about electrical efficiency.